Alright, and welcome back to another video talking about Node.js and specifically looking at GraphQL section here. What happened? Okay. So, the TLD of GraphQL, well, is a new query language that allows us to build front-end and back-end. And the beauty of this is that we can see how all of our different pieces of data in our server relate each other. So it all starts by describing the data using schemas, and if you want to ask for that data, you rely on queries. So query is much like selecting property on an object. And the great thing of this, because the query really match closely what the return object will get, we can predict what our query will return. That including is the name of the property, regardless how the data is stored, whether you're using a document base such as MongoDB or relational database like MySQL, Postgres, key values such as Redis, Y color like Apache Cassandra, or graph database such as Neo4j, Neo4j, like this, right? A graph database platform. So I saw that the benefit of this is because it allows developers, sorry, since this is a new way of building APIs and how do we interact with them, developers now have this new particular way of doing things, which was created by Facebook in 2012. And the main issue that it solved is the underfetching. So when we send requests to query multiple collection of values, we lose additional time making extra additional round trip. That's one. And the other is that is overfetching. And this is when you ask for a collection of value, when you hit an API endpoint, you get additionally unnecessary data that you need to filter out in the client. So to solve this issue, which it relies on the performance aspect of the web, of your web app, well, GraphQL defines just a single entry point, so no more overfetching, no more underfetching. It provides you type and schemas and speed of development. The disadvantage of this is this flexibility comes with complexity, because now developers, which most of the time are familiar or they are familiar with RESTful architectures, how to build API using that particular architectural design, and now they need to do that the GraphQL way. And catching is something difficult. Again, RESTful, there are several proven catching methods that now, as developers, we need to know how to do that in the GraphQL way. Also, since this is not a RESTful architecture, again, the learning curve here might be quite steep to get yourself familiar with, but it's not impossible. I saw that since Facebook created this in 2012, and by looking at the specifications and how can we use GraphQL in React framework to create the client side of GraphQL and more high-end products such as Apollo, where it allows us to build front-end and back-end GraphQL server. So before I dive deep into there, I saw how can we create our first query by looking at the graphical, and how by default it performed a query, meaning it fetched data. Then I saw how can I perform this GraphQL server, how can I set up a GraphQL server from scratch by using its Node as platform, Express as a web framework, GraphQL tool for GraphQL, specifically the npm package, by defining its type system, something that we have here, by defining the simple example of type systems, and understand the reason why we need to define is the query, because this is one of the root level operation in any GraphQL server, and with the defining is the schema or the type system, it describes the capability of this GraphQL will have that is used to determine if a request operation is valid, if the validate the return type response of the response, validate the type of the response result, and something that we are looking here on our type system, this, and describe the input types of variables to determine if a value provided at request time are valid. This is something important to understand. What is the capability, or yeah, what is the use of the type system? What is doing behind the scenes, right? So yeah, I look at the simple example. How can you create your graph query from scratch? Good, cool. And uh, and also how you can query your GraphQL endpoint using HTTP protocol, particularly HTTP post request. So if we look at the HTTP specification, like this, right? If you look at the HTTP specification, which is the standards here, and navigate directly to the verbs, in this case post, okay, which is method definition, a post here, all right. Now this, all right, now this is what we use in Postman, this front-end tool for testing your queries, or for testing APIs, and see that by using an HTTP post with inside of the body, we define this raw JavaScript object notation, JSON, and we get the data that we want. And that's what's pretty cool, because knowing the basics, now you can stack up your knowledge into more realistic scenarios, into more realistic projects. So deep nested objects are very common in any e-commerce application, which is something that we're going to design. Designing an e-commerce schema. It's very common, or in any application with some technical depth, which makes GraphQL the perfect candidate. Since querying of data is very, very easy, querying really complex data structures is very, very easy, our API now is organized in types and fields rather than endpoints, like in a RESTful architecture. So to make our application much more modular and scalable, I rely on tools like GraphQL, which help us to answer these couple questions. How can I split my type definition or my type system into multiple files? how can I organize my server per feature, and how to set up your server when you need to add more complex logic to fetch your data. So GraphQL help us to do that. First with schemas, and with that, well, you need to define is the GraphQL file schema for that, where you're going to set the types and fields, okay? And then rely on NPM tools such as load file sync, which when you pass an argument to look up for the files or the GraphQL file that you're interested in or your types, then you're gonna load all of that sync. So meaning you tell to know, hey, it's gonna wait for this data until you get all of that, right? And with a function called makes executable that comes from these GraphQL tools, we can pass that array of types, right? So that's pretty basically what we do here. Okay, we define is our huge type system for our e-commerce applications, and we split that per features, products, and orders. The great thing of this is that this approach makes sense as long as you define, as long as you have well-defined types, well-defined GraphQL files, and there is no name conflict. Okay. Then I look at how can I modularize or GraphQL server, but with resolvers. And you may wonder, what are resolvers or what resolvers are? Well, the answer lies in how do we query our server. So GraphQL always determine in a GraphQL server, or GraphQL always determine if a GraphQL query is valid by looking at the schema and then execute that query. So when executing the query, the value of the property is determined by a function called resolver. So when you have your GraphQL query and you define all of your property that you need, each one of those properties has a proper resolver, and once the server has called out all of the, once the server has found out all of these resolvers in the query, then it wrap up and send back to the client. And this pretty much basically is a resolver. So we define as a resolver in our method executable function, but we quickly saw that that is not what do we want. That's actually, it's not scalable or maintainable and readable. Okay, so because of that, I look at a way of how can we modularize that. But first, look at the anatomy of the resolver. And that is the arguments from that resolver function. When you have the parent, this is when you pass some root values to that. The other is the argument. It's being used with parameterized queries. So for example, when you want to filter data under some conditions, so context is the data shared across different resolvers. For example, passing authentication data about which user log in all resolvers, and the info, which contains some information about the state of the operation. Now, then abstract that into a file called resolvers, where the beauty of this is that we can perform API calls. any asynchronous call, and we need that, right? With that, so knowing that, right, and knowing how can we organize and modelize a GraphQL query resolvers, okay, especially for large project. So I also look at how can I filter out data, meaning it's filtering data with queries and resolvers, so to see the entire pipeline and to get your hands dirty. And this is all about, well, defining is a product by price. If you define as a query, pass the arguments, that mean the maximum, max price, and the return type, which is a list of products. So it all starts by defining is the query, okay, in your types. And then go to the resolvers, so you can now from the resolver call this function from the access data layer and define the function from the data access layer, in our case from the product.model, implement the logic and return that is as a part of the model from that model. Exactly. So implement that feature, or implement that logic in the model, and then return that as part of the model. Model, model. The subtle difference between model, model. Well, in our case, because we're using it for the sake of the example, is built-in memory list of products. We're taking care of that. And also, well, do that for the product by ID. So get one product by ID. So that was actually interesting. And then, uh, because GraphQL is not only for fetching data, and especially when you are implementing these backend applications, you can perform CRUD operations, meaning create, update, read, create, read, update, and delete. These CRUD operations in the GraphQL way are very different in a RESTful, because the way of GraphQL doing things is, since querying and gathering data, reading data, and gathering data from an API is probably the most basic operations you're gonna do. Okay, or it's probably blah, blah, blah. It's probably the most common things you will do. That's why GraphQL focus on doing queries really well. How can you do that? Particularly the, the create, the update, and delete operations with mutations. And again, mutation is another type of root level operation in your GraphQL server. So I also look at how can I implement a mutation, okay, which it was pretty cool, okay. Again, by looking first to understand what is the capability that our GraphQL, uh, what are the capabilities that we want to implement in our GraphQL query or in our GraphQL server. Okay, that we're going to add a new product and add a product review. Okay, makes sense. So first I look at how can we implement is this mutation, using is the add new product. You define is in your GraphQL file extension the mutation and the necessary argument that it needs to do that. And the return type, as part of a fairly common pattern, is to return the, in our case, the product. Anytime you add a new product. The reason is it indicates that that data was saved. Okay. So what's come next? Well, look now for your resolvers, and here is right below your query property. You're going to define is the mutation as a map or an object where it takes the name of the mutations and the resolver function. But what is in the body function? What is the body resolver? What is the body resolvers going to look like? Well, here is when we define is this function in the data access layer that will take care of all of our logic while keeping our resolver files small, thin as possible, because by making this model like that, uh, there's no need to overcomplicate things. There is no need to overcomplicate things. Why do we set this? So by defining is this function, okay? So by defining inside of this resolver function, by defining is inside the resolver body, the or a function from the data access layer, we can make our resolver file much more thin, small, and modular, and be independent to whatever implementation we want to add or model or database. Again, this is following is the highly cohesion and low coupling principle, meaning cohesion is the degree of relationship within that model, and coupling is the relationship between models. In any case, it is important to refresh those concepts. So now, once you're going to define is the logic from that function, you add new product here, you do that, and if you want to test that, okay, now when it comes to test that, you define is a mutation keyword and the name of the mutation as their argument and the value that you want to get from that. So that was pretty interesting because we get back as a JSON output. Okay, cool. Now there was a new exercise here that the mention is okay. So let's going to add a new product review, and here we're gonna see well how to write a mutation again. And towards the end of that video, when I saw that, dive deep on how mutations are executed and how to execute many mutations at once. So after I implement that, you can check out here. It's status. I already pushed that. Okay. So once I implement that, because here is adding a new product review. So you look at the product review here. So the product GraphQL, we add this new mutation. Okay. Add new product review. Okay. We add this mutation, and in our resolver, we define is the name of the mutation, and inside of the body, we set or we call is this function from the data access layer, the add new product review, okay, where this we're going to take, or this is where you're going to set up the logic for this. So if there is a matched product that you get product by ID, then if matched product, create this new product review, and well, you're gonna push that in there. Again, this is only to consider is if there a new, if this is uh, um, is a product match, because if not, well, you're gonna return nothing. And here you're not handling is errors for that. None of this you're handling error. You're handling is the real life, or you're handling is the best possible scenario in GraphQL. Yeah, perhaps this might be an advanced topic. hmm For Apollo graph, error handling in Apollo graph doc. Built-in error code. One of the great things of this is that it allows you to build-in error code by user input, persist query not found, persist query not supported. hmm Throwing errors. Throw new GraphQL error. And this is the way of how do you do this, including custom error details, an argument name. hmm Okay, with GraphQL, with Apollo, we already have this, which simplify our life vastly. For client response, hmm for Apollo Studio reporting, example noting common law sovereignty error. This is from the Apollo, okay, for Apollo Studio. Client response. hmm Settings to be status code and header. Okay, but that's from Apollo. But in GraphQL, since GraphQL is the specifications, they tell you how to do that, how to handle error, and then with validation here, in operation, handling field errors, response errors. Okay, response errors. The errors entry in the response is not empty. List of error, where each error is a map. If no error were raised during the request, the error should not be present in the result. In the data entry, If the response is not present, the error entry in the response must not be empty. It must contain at least one error. The error it contains should indicate why no data was able to return the return. If the data entry in the response is present, including if the value known, the error entry in the response may contain any field error that were raised during execution. If fields error were raised during execution, it should contain those errors. Mm. Mm. Mm, 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 mm. Okay, you can handle errors for that. Mm. Mm. Again, what GraphQL does is to abstract that layer of complexity. What it does is to abstract that layer of complexity. It's officially deprecated. It's officially deprecated. Mhm. Yeah, that's one of the things that if you marry to that, it's like, okay. If you marry to that, if you marry to that, it's like, okay. If you marry to that technology, it's like, mm-hmm. If you marry to that technology, it's better you to look for tutorials, for things like that. Mm-hmm. Mm-hmm. Exactly. Now they are looking at, so you can see the Apollo for that. Mm-hmm.
Welcome to understand what our GraphQL receives the HTTP request. It first extracts query is malformed. The server with the correct data from the correct source, such as the response with a, and that's the story of the journey of Now we know the story behind and how is base, a third-party API, webhooks, and so on. These are called data sources. The beauty of GraphQL at the documentation for this API, it impacts how and get a JSON response back. We also get a bunch of data to match only author and returns the detail of that author. And stitch the results together so we know how this data is structured. So now it can use a handy help retrieving all tracks by calling all. Now, what if our 100 tracks and the query should look like this? I actually already sets cache headers for those and the duplication of our REST API calls taken care of out of the box for you.
Let's add this REST data source class -data source. In there, we'll create a class called tracker that we get access to our REST data source feature. All right, time to define the get. And these are the two methods that will be used by our resolvers. And that's it. We've got our data source set up and retrieving data from the REST API.
We have our. It has the same name as types and fields. To make what it does very clear. Let's go over each in client land information for a more positional argument that we will be.
In S here, we need the context to our track home resolver REST data source as possible. By doing so, you make your API more resilient to future changes.
To the context parameter. Well, right now, we've got our resolver, the Apollo, the data source, plan. In server/src/index.js, where we configured our Apollo server in part 1.
Then you define some of your index.
We can now replace our mux with resolvers. Let's remove the mux object, as well as the mux property in the Apollo server constructor. And next, let's import our resolvers file at the top and then add it to our constructor. And that's the resolvers taken care of. Next, we'll require our REST data source file and call it track API. Note the Pascal case convention as we're dealing with the class here. To connect our server with our track API and its methods from the context parameter of our resolvers. Apollo server takes care of all the plumbing for us. So that's what our server configuration looks like when it's finished.
Yeah, because I look at the foundation, how to create GraphQL from scratch. I'm not able to understand.
We've implemented our resolvers,
but
there's a secret shortcut to
Apollo layer, which makes things much easier to maintain.
Apollo Studio Explorer. Indeed running, and that even though our REST endpoint wasn't, then this would fetch. Now we really see why we should keep using the REST data source implementation.
Exactly.
So far, it can run into invalid field. We know that it exists in us with the response that's returned. We have codes that will help to fix a user input of an invalid format or circle back with our backend team to of what went wrong, like a user input of an invalid format, for instance. Finally, note that so we took a shortcut to serverland with navigate to handle making these API calls more efficient. We created a resolver to connect.
Exactly, but most of these are in the GraphQL arguments, mutation. What is a mutation? Updating a track API data source. Resolving a mutation successfully. It's kind of the same thing handling case.
As we saw in the REST API, the appropriate
The
response
only
for our
thing that we
increment
didn't
track views
show is
mutation
that
ready.
how to handle errors.
To handle the situation where the track API call throws an error, let's wrap the section in a try block. When the error is thrown, we'll make sure to catch it by adding a catch, which takes the error as a parameter. Then, we return a new object with the
Because this is
same
an async
properties as the one
operation,
above,
you
but with
can
different values. We could set the code to be 404, but we can also be more dynamic and use the values that GraphQL
exactly.
provides us
Instead of
with.
limitation,
When there is an error, Apollo Server attaches an extensions field to that error that contains relevant details. In this case, it contains a property called response, which provides some information about the HTTP response from the track API. We can return the status property, which refers to the for the extensions.response.body property. Finally, we'll add a track property, but set this to null, since the object was not successfully modified. Awesome, this mutation is ready to go, and ready to be tested in Explorer.
Now that we have our schema, there's first syntax should fill list of mutation, this mutation. Data track back. When we run the mutation again and again, we can see that the number of views is going up, and the message says could not find track with specified ID. The change the ID to our silly string doesn't exist. When we run this mutation, we see the response has a code 404, success is false, and the message says could not find track with specified ID. Playing with Explorer page.
React for that.
We'll need double to hold our mutation. Calling the hook, it takes in the mutation we set up a track prop. Is an object with information about the mutation. One last thing, let's add a console log to check the mutation response when it's completed. To do this, let's go back to where we set up our use mutation hook. Let's see the number of views.
Yeah, but this actually is something.
That means we didn't send unnecessary queries to our GraphQL API. Similarly, we're still getting our page loaded from cache while our mutation is sent off. Apollo client is doing the work behind.
You've working application to production. See you in part 5.
Okay. I'm looking right now, is this federation in production?
Welcome to the final part. A single track and its modules using. To help us with that, we'll use a central piece.
Well-known third-party solution.
Them locally. Navigate to the folder. Now have our client app running in the browser on localhost 3000. Our app, along with to support system forms and fields that were added, modified, and removed. This is what powers almost every feature version of our schema. To the registry, we can run a potential change. So our graphs, enabling Apollo to surface potential conflicts between. In this course, I changed his graphs, enabling Apollo to surface.
Client app, this is a monolithic app. But this is a monolithic app. Mhm. Okay, okay. So after I saw this, especially in how you can create your mutations, that was something that took off way took off, especially on GraphQL. So understand GraphQL and all the subtle things that they explained, which it all start with the basics of GraphQL, right? And how you can create GraphQL from scratch, and then how you can include your uh, you can include Apollo, this industry standard. This is mhm, Apollo, this industry standard of GraphQL implementations, providing the data graph layer that connect modern web apps to the cloud. And there are some more advanced tools if you really want to commit to their platform that help you build graph project as part of a much larger team. So what I'm looking, so the thing that I'm, yeah, the thing that I'm looking here right now is the thing that I'm looking right now is that Apollo, okay, is this industry standard GraphQL implementations providing the data graph layer. Important topic here. Providing is the data graph layer that connects mother app to the cloud, or mother app to the data source, to whatever data source. That's another important topic here. There are some more advanced tools if you really want to commit to the platform that help you build GraphQL as part of a much larger team. Okay. And then I look at the Apollo clients and the Apollo server. So the Apollo server. And again, I'm taking carefully step here because this topic can be a very vastly this can be a very vast topic. This can be a very vast topic. hmm This can be a very vast topic, and I need to take it one bit at a time.
We pause for a second, but we remember that we're ready for this. All right, what's the first thing that we need to know? Well, what exactly is Apollo, and how does it relate to what we already know? Apollo is another GraphQL implementation, very much like Facebook's reference implementation that we've been using so far. However, Apollo is much, whether you're using React or Angular on the web, iOS, or Android, benefits like caching your queries, handling loading states and errors, and keeping your data synced with the server. It makes the data that you fetched available to your front-end components, whether you're using React or Angular on the web, iOS, or Android. It handles connecting your components with the data that comes back from a GraphQL query without having to hook things up manually. That's Apollo Client. What about Apollo Server? Client is components of Apollo that you'll see in your development career are this Apollo Server and the Apollo Client, which is where we'll start because the client is where Apollo's benefits really shine. Apollo Client is a set of front-end libraries that help.
So Apollo Client is a set of content library
Make GraphQL queries and save. Apollo Client is a set of front-end libraries.
Okay, it's a set of front-end libraries, multiple libraries. So Apollo client is a set of front-end library, and when you talk a client, is most of the time like that. It's a set of front-end library. So it can be from laptop, mobile, or any front-end device, any terminal. Okay, it's a set of front-end libraries
that help make GraphQL queries
that helps make GraphQL queries
and save GraphQL data in your frontend.
And save data and save
of front-end libraries that help make GraphQL queries and save GraphQL data in
and save GraphQL data
your frontend.
in your frontend. Important thing here. So the Apollo client is a set of front-end libraries that help you make GraphQL queries and save GraphQL data in your frontend. Catching.
Using Apollo is much more convenient than making post requests.
Exactly. Using Apollo is much convenient than you making HTTP post requests to your GraphQL endpoint directly.
To your GraphQL endpoint on your server directly. It lets you query.
It lets you query
your GraphQL server.
Exactly. It lets you query your GraphQL server, much like a graphical.
With your front-end application, much like you would through graphical.
Much like you will in graphical.
And it comes with added benefits like.
And it comes with added benefits.
Caching your queries, handling loading state.
So catching your queries, handling loading state and errors, and keeping your data synced with the server. Where can I read about all of this GraphQL stuff, Never worry about catching, never status, or getting data into your UI ever. Okay, so it takes care of so it comes with this added benefit like catching, loading states of network status, and getting data in your UI, and keeping data synced with your server. It's a way to consume a graph. Apollo and GraphQL. They deliberately don't tell you what. Apollo as a company gives you multiple libraries to this that are suited to wherever you're building your app, web, iOS, and Android. Apollo client is about binding your data to your UI with GraphQL. GraphQL. Glassdoor. With Apollo Federation. Cache policy, reactivity, pagination, subscription.
And errors, and keeping your data synced with the
So
server.
that
It
is
makes the data that you fetched available to your front-end components, whether you're using React or Angular on fetched, available and application to your GraphQL
or Apollo client view. View Apollo. Getting started with a view Apollo. Mhm. You know what GraphQL is. You're familiar with Apollo client and that you know how to query mutations. You're familiar with Vue and some other compatible front-end library and framework to build UIs like React and like you have Node.js version with Vue CLI. Options versus composition API. Mm. Okay, what you're doing is just inject that in V2. And it comes from this. Default work line into the client. Usage outside of the setup. How you can perform queries. It's one of the benefits of using this. And then hooks, lazy query, so query, mutation, subscription, client setup, use subscriptions, pagination, full survey, previous type process, fragment, reducing fragment, or getting fragment, and error handling. Knox, uh, Apollo. Well, it's probably the same as that. GraphQL integration. into your Node.js project. Start on GitHub. Documentation. Mhm. Mhm. Okay. I know that also Node.js can create that type of things, the GraphQL and things
server
like that.
with your front-end application, much like you would through GraphQL. And it comes with added benefits like caching your queries, handling loading states and errors, and keeping your data synced with the server. It makes the data that you fetched available to your front-end components, whether you're using React or Angular on the web, iOS, or Android. It handles connecting your components with the data that comes back from a GraphQL query without having to hook things up manually. That's Apollo Client. What about Apollo Server? Apollo Server is its own package on GitHub, which allows you to create a GraphQL server in Node, very much like our Express GraphQL package. But Apollo Server can work with Express or Koa or pretty much any other popular Node framework. Even better, it helps you run and deploy your GraphQL code to serverless environments, like
Something that I didn't take note of yesterday. So Apollo Server allows you to create GraphQL server in Node, much like our GraphQL package. Even better, it helps you to run and deploy your server code to serverless environments like Lambda. It includes functionality to help you implement subscription in your server and other root level operations, where subscriptions allow you to push data from the server to subscribe client, much like push notification in your phone.
Amazon's Lambda service on AWS. And it includes functionality to help implement subscriptions in your server. Subscriptions are the third type of GraphQL operation. We had your normal read queries, we had mutations, and we have subscriptions, where subscriptions allow you to push updates from the server to subscribing clients, much like push notifications on your phone. Subscriptions are a very advanced GraphQL topic that's needed much more rarely than mutations and queries. Now, all of these things are possible with Express GraphQL, that package that we've been using so far. But Apollo Server wraps up all of this functionality into your GraphQL server and exposes it individually in a set.
So Apollo server wraps up all of the functionality of a GraphQL server.
Wraps up all of this functionality into your GraphQL server and exposes it individually.
So Apollo server wraps all of this functionality in your GraphQL server.
in a server wraps up all of this functionality into your GraphQL server and exposes it individually in a set of NPM packages.
And expose it individually in a set of npm packages.
There's this page on the Apollo GraphQL website which explains how to choose the right package for you. We have the battery.
So the integration middleware, Apollo integration middleware. But no, that's already deprecated with this. Integration middleware. Deployment security, performance, web frameworks, integration building, integrations, defining schema, resolving operating, performance, security, deployment, lambda hierarchy, API reference, use report, Apollo GraphQL docs, Apollo server. This is from the Apollo server. Okay. The Apollo server, integrations, integrations. View integration. Mm, 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 mm. Exactly. But those are for version 3. Apollo Server 4 includes 2 building integrations: Star, Standalone, and Express Middleware. So when I look at the version 3, the integrations are quite different. Integration. Okay, Apollo Server integration.
Is included Apollo server package that includes just about everything, but then we can choose some different options. There's Apollo server, but there's also Apollo Server Express, which allows you to use Apollo server in an existing Express API. This is the most widely used version of Apollo server. But we also have serverless specific packages, where we can run an Apollo server on AWS Lambda, or Google's offering, Google Cloud Functions. And there's plenty of other options for other Node.js frameworks, whether it's Koa, Happy, or Fastify. The good news about all of Apollo's extra features is that they have this excellent website right here. If I zoom out, we can see that it has this really
Choosing which package. that must be from older. Yeah, that must be from older. Integration. Basic use of the Express async support is not built around promise and async.
Really excellent documentation on all the different features of Apollo, regardless of which aspect of it you're using. And the even better news is that when it comes to Node and the backend, Apollo will feel quite comfortable to us with our experience so far. The server-side component is very, very close to the GraphQL code that we've been building. So let's keep it going and see Apollo server in action in the next video. See you there.
Okay, and with that, I'll see you soon. Take care. Bye bye.